Hey guys! Thanks for coming back to my channel, Algebra 1 Tutorials with Alina. If you like my videos, please like and subscribe. Today we are learning about domain and range. Domain is the set of x-coordinate values in a data table, set of points, word problem, or graph. So if we look at this graph over here and this set of points, we can see that the x-coordinate in the data table would be this line right here. And so the domain of this would be 3, 4, 6, 8. So let me write that out here. And you will write them in these parentheses. So they will be 3, 4, 6, and 8. And you can see in this data point that the x-coordinate is 3, and so the domain would just be 3. Now range is the set of y-coordinate values in a data table, set of points, word problem, or graph. So essentially, they're the same thing, except in domain you use the x-coordinate values, and in range you use the y-coordinate values. And so again, as you can see in this table and coordinate point, you can see that we have the same values in the table and the same point, except that this time the range is going to be the y set of values over here. And so our range would be 5, 3, 2, 9. And for our coordinate point, the y-coordinate of the point is 5, so the range would be just. So the way you would format domain and range when you're trying to find it is through discrete and continuous. And so we talked about discrete and continuous functions last week. And so for discrete data, the domain will be written as a data set list, or as individual points. Continuous data, however, would be written as inequalities, or ARN, which stands for all real numbers. ARN is used when the domain or range of a function contains all possible x or y values. I'm going to show you guys an example on this graph, and you have the arrow marks right here. These show that the line keeps going forever. And in the direction that it's going right now, you can tell that sooner or later, at one point or another, the line or function will cross every possible x value, positive and negative, and every possible y value that is positive or negative. So if I want to find the domain, or if I want to find the range, both of them would be equal to all real numbers. So let's move on to the next page and do some practice problems. So problem 1 here says fill out the table, and we're using stuff that we previously already know, and so let's fill it out. It says domain, and its opposite would be the range. The range is the y value, it is the dependent variable, and it is the output in a table. Oops, I spilled the pen. And it is the output in a table. The domain is the x value, on the other hand. It is the independent variable, and in a data table, it is the input. And so let's fill out problem number 2. It says complete the sentence and find the domain in each situation. And so we're going to fill this out for domain. It says domain is the set of x values, x coordinate values, in a data table, set of points, word problem, or a graph. So let's look at the first one, and first let's determine if it is discrete or continuous. As you can see here, it has these 2 points right here, and multiple points in between, and it also has a line connecting it, which shows that it's a continuous function, and even in between the 2 points there are other possible values. And so we can determine that this is continuous. It is continuous. And so for continuous, we are going to write an inequality. And so our inequality is going to look a little something like this. So we're finding the domain, and so we're going to go to the last point on the left side, and we're going to look, and it ends up at -2. And so our first value that we're going to write is -2. The point is a closed point, and so we're going to write -2 is less than or equal to, and then we're going to write x, which is going to be the domain of this entire function. And so x, -2 is less than or equal to x, which is less than or equal to, and then we go and we find the highest point on the right, and that ends up to be 2, and it's also a closed point, so it will be x is less than or equal to 2. And so the entire domain for this continuous function is -2 is less than or equal to x, which is less than or equal to 2. Let's move on to our next problem. This is a data table, so we can tell that this is a discrete function. And to find the domain of our discrete function, we just write down the x values of our data table. And so the x values in this case are 1, 4, 6, and 7. And so that would be the domain of this problem. Our next one, we can see it is a graph, and it is a line graph which is continuous, so we can determine that this is a continuous function. Now this example, it has the 2 arrows right here, which show that this graph goes on forever. And at some point or another, you can see that the graph is going to cross all of the positive and negative values of the entire graph. And so we can determine that the domain in this situation would be all real values of x. So they would be all real numbers. So I have one more problem for you guys, and let's go to the next page. So problem number 3 here says complete the sentence and find the range in each situation. So we're going to be filling this out for range, and it says range is the set of y coordinate values in a data table, set of points, word problem, or a graph. And so we're going to start filling this out here, and we're going to first determine whether each graph or data table or set of points is discrete or continuous. And so our first one is a graph, and we can see that it is a line graph. And so we are going to say that this is a continuous function. We can assume that this graph keeps going in the same direction because it doesn't have an endpoint to stop it at the top. And so we're going to assume that it keeps going upwards in that direction. So to find the range, we can see that if it keeps going, this function, it starts at 0. The range is at 0, but it keeps going upwards. So it's going to go on forever. And so then at some point, it is going to cross all of the possible y values that are only positive, which are greater than 0. And so this would not be considered all real numbers because it does not cross any of the negative values, and that is part of the graph. And so the way we would write this is it would still be an inequality, but the inequality would be shaped like this. It would be y, which is going to be the domain, is greater than or equal to 0, which is its starting point at the bottom of the graph. So this would be the range of our line graph. Our second one over here is a set of points. And so we can determine that since it is a set of points, this would be discrete. And to write our range is fairly simple, and we can just write the y values of each of the coordinate points. And so the range in this situation would be 5, 6, 7, 8, and 9. And you can see I wrote each of these in from least to greatest. Our next one right here is also a graph, but instead of a line graph, this is a coordinate graph with separate points plotted on it. And so we can determine that this is a discrete function. And so to find the range in this situation, we are going to take the y values of each of the coordinate points. And so let's start from down here. Our y value of the point F is -5. And so we're going to start writing them, and we're going to write them least to greatest. And so our first one is -5. Our second point, we're going to use point D, and it's going to be -3. Our third point is point E, which is 2. Our fourth point is point B, which is 6. And our fifth point is point A, which is 7. And so these together would make the range of this function. I hope you guys understood the videos. Please like and subscribe down below, and comment any other Algebra 1 topics you would like me to go over, or any other additional questions you may have on this topic or on any topic in general. Thank you so much for watching. Bye!